Okay, guys, it looks like, well, I had 4 people there a moment ago. I'm back down to 3. But what I'm going to do is I'm just going to get started here uh, in relation to some other content. Okay. Uh, so I mean, up to this particular stage, to now, really all we've looked at is generating tables and graphs. Okay, that's all we've sort of looked at. Okay, up to this particular point. Yeah. Okay. But what I want to do first of all here this evening is to have a look at some numerical measures, some numerical uh, descriptive statistics. Right, the statistics. Right, and in particular, I want to have a look at measures of center. So we have measures of center and measures of dispersion and measures of dispersion. Right. So the measures of center that I'd like to focus on are what's known as the mean, the median, and the mode. And the measures of dispersion that I want to focus on for this evening's class is what's known as the range, the variance, and the standard deviation. Okay, the standard deviation. Now, for our presentation, we're just going to have a look at some raw data, and we're just going to do these particular calculations. Okay, so we'll have a look at some raw data. So let's say some raw data. The data was captured from a question that was asked. The question was asked of our sample. So the question was asked of our sample participants. And let's say the question was, how many brothers and sisters do you have? So how many siblings? How many siblings? Yeah. Okay. Because we're probably interested in the number of siblings, because it's probably the case that the more siblings there are, yeah, that the more financial pressures they're going to be on a particular family, and in particular that them financial pressures are going to impact maybe the education opportunities for the siblings, for the particular children within the family. So it's just a variable that I'm measuring. It's a question. Don't forget, every question is a variable being measured, and in particular, we're looking at how many siblings are within a particular sample, or the people that within the sample itself. So I asked the question of the first person. The first person says 4. The next person says 3. The next person 3. The next person 2. The next person says 1. We have 4. Let's say 5, 7, and so on and so forth. We could continue, but in this case, what I've done is I've randomly selected 1, 2, 3, 4, 5, 6, 7, 8. So I've randomly selected 8 people from my population, and I've asked each one of them the question, how many siblings do you have, or how many siblings are there or how many siblings have you got? So the first person said 4, the next 3, the next 3, the next 2, and so on and so forth. Okay. Now, what we have done up to this particular stage is that we've taken a data set, okay, a set of numbers, okay, measures associated with some question, and we've produced some relative tables, yeah, tables that allowed us to summarize those particular responses, so that we could see important characteristics. We had a look at frequency distributions. We had a look at relative frequency distributions, cumulative distributions, relative cumulative distributions. We also plotted the data set using graphs. We had a look at some bar charts, some histograms, and we also had a look at what's known as scatter plots. Okay? And these particular, let's say, tools, tables, and graphs allowed us to identify the characteristics, the important characteristics associated with the variable that we were interested in. And here's a very simple variable. But what we're going to do now is we're going to concentrate on some measures of center, 3 important measures of center: the mean, the median, and the mode. Let's just deal with the mode first of all, from the raw data perspective. Okay, so the mode is simply the most frequent response. So the most frequent response that we have associated with the question that we asked, the most frequent response associated with the variable that we measured. And in this particular case here, when we go through the data, okay, we're looking for the most frequent response. Actually, what we could do is we could take this data here and we could put it into a frequency distribution. Let's just do that really quickly. Okay, so frequency distribution. I have my observations go down this column and our frequencies go down here. So the possible numbers of siblings are down here. So let's say X is siblings. So we have the numbers of sibs. So you either have, let's say, 1, 2, 3, 4, 5, 6, and 7. Okay, and down this column here is our frequencies. How many times did someone respond with one sibling? It was only one person, so we have a 1 here. How many people responded with 2? There was only 1. There it is there. How many with a 3? There was 2 people that responded with 3, so we have 2 here. How many with a 4? There was 1. There was 2 people with a 4. How many with a 5? There was 1 person with a 5. How many with a 6? There was 0 people responded with a 6. How many with a 7? You can see there was 1 response with a 7. So the modal response, okay, the mode, this tendency of people to respond with the same value, if that makes sense. So it's a tendency. So these are called measures of central tendency. Okay. So this tendency with respect to the most frequent. If you think about the most frequent being an attraction, whatever that number being was attracting people to give that particular response. In our case here, you can see that, well, the number 3 occurred twice and the number 4 also occurred twice. So in this particular case, we'd say that the distribution, okay, is bimodal because we have 2 modes, okay? And in particular, the modes are 3 and 4 siblings, okay? They're the most frequent responses that we have in that particular data set, okay? So it's a very, very basic statistic, okay? But the important thing about this statistic here is that the statistic can be applied across all of our scales of measure, irrespective of whether it's nominal, ordinal, ordinal, interval, or whether it's a ratio scale of measurement. Irrespective of which scale of measurement is associated with the variable, with the question, the mode can be applied to them all, okay? Because it's the most frequent response, right? So keep that in mind. So that's an important statistic. It's a very basic statistic for us, okay? But it's important. It gives us an idea of where people are attracted to when it comes to the variable itself. In this case, there's a tendency for people to respond with a value of 3, indicating that they've got 3 siblings, or a value of 4 in this particular case. Something about the mode is that the mode doesn't always exist. For example, if everything occurred once, we'd say that there's no mode. The mode only exists when we have a clear winner, when we have a situation where a response occurs more than once within our data set. Okay? If, for example, this was the data set here, 4, 3, 2, 1, 4, 5, and 7, clearly 4 occurs the most frequent amount of times. In that case, is a single mode. This distribution, this variable is unimodal. Okay, this is the most frequent response. Now, when it comes to our histogram, okay, if we had a histogram, okay, in a histogram, the highest bar, is an indication of the modal response. Okay, now in this case, we've got 2 modes. So the distribution, if we were to have a look at the histogram might look something like this. We have 2 bars that are of equal height, and that would be an indication that it's bimodal. Here's our nice bell-shaped curve. Here's a curve that sort of has 2 humps in it, okay, to indicate the presence of bimodal characteristics. Okay? We can have 3 modes, 4 modes, 5 modes, and so on. Okay? So that's our first statistic, which is the mode. It's a numerical measure now. It gives us the actual response within our data set that occurs most frequently. Okay? And that response, as I said, is a tendency. It's where people are tending towards. Right? So that's our mode done. Let's take the next one, which is our median. Okay. Now, when it comes to this raw data, to calculate the median, let me just take this over here. Okay. Okay. To calculate our median value. Okay. So we're going to calculate our median. What we're going to do is we're going to order the data set. So we're going to order the data. Okay, from smallest to largest or largest to smallest. So let's just order the data. So we have 1. Okay, the next response is 2. The next highest response is 3, followed by another 3, followed by the 4, followed by the other 4, followed by the 5, followed by the 7. Okay. So the median is the middle response. Okay. So it's this response that splits the data set up into two equal halves. Half the respondents responded with a value less than the median, and half responded with a value greater than the median. To find the median, we triangulate off. Okay. So we triangulate. We get rid of the smallest value with the largest value. Actually, this is a good characteristic of the median, because sometimes when we collect data, okay, so let's say, for example, if we were to look at average wage, okay, and we were to ask participants how much do they earn, okay, well, typically, well, in Ireland, and anyway, okay, the average wage, I think, is in around between 35 and 40,000 euros a year, okay, but we know that some people have a wage that is 10 times, it's multiples of that particular average, but there's not many of them. And they're called outliers within our data set. And the outliers influence the average. One good characteristic of the median is when you go to find the median, you immediately cross off the extremities within the data. And the extremities are where the outliers would reside. So we cross off the first two, we cross off the next two, we cross off the next two. And if this was a data set with an odd number of cases, we'd end up with one in the middle. In this case, we have 2 in the middle. So the median is going to be halfway between those two values. If you want to find what's halfway between two values, you add them together and you divide by 2. Okay? So in this case, we're going to end up with 3.5. So the median, okay, the median number of siblings, okay, is 3.5 siblings. Okay, that's the median. So now we have two statistics that we've measured. We have the mode, tells us where people are tending towards when it comes to their responses. We have two modes, 3 and we have 4. And then we have another way to look at it, which is from the median perspective. And the thing about the median is this, is that what we know about the median is that half the people are less than that, half are less, and half are greater. Okay, so the median splits the data set up into two equal portions. Half the responses are less than the median, and half the responses are greater than the median. Okay, now while we're on this here, okay, this concept of the median splitting the data up into 50% is less than it and 50% is greater than it, it's probably nice for us just to maybe to go off on a side and to have a look at what's known as, okay, instead of breaking the data up into 50% being less and 50% being greater than, what about if we divided it up into quarters? What would we get? And then if we divided it up into tenths, what would we get? And if we divided it up into units, what would we get? So we have a number of ways to look at it. We can divide the data into half, into quarter, into tenths, and into, let's say, just units. Okay. Well, when it goes to quarters, we call them quartiles. When it goes to tenths, we call them deciles. And when it goes to units, we call them percentiles. Okay, you've probably heard that word percentiles before. It's just another way to look at the data from an ordering perspective. So let me just draw over here while we're on this here. Where's my ruler gone to? Here it is here. Let me just draw an axis here, just so that we can see this. I'm just going to draw an axis. Okay. And I'm going to just maybe put some graduations on it here. Let me just put some graduations as we're going through. Okay, all the way through here, so that we can see this in action. Okay. Let's just go through here. Let's just go to 19. Okay, let's just say this is 0. Let's say this is 20. This is 40, 60, 80, 100, 120, 140, 160, 180, and so on. We could actually, let's just go out to 200 here. Okay. So I'm going to ask a different question this time. And I was at a wedding recently, and usually when you go to a wedding, you might give a gift, yeah, okay. But I'm interested in how much people typically give when it comes to gifts, yeah, okay. So the gift that you might present when it comes to a wedding. Okay, and I'm just interested in the characteristics of this particular type of distribution. Okay, so what I'm going to do is I'm going to ask people the question: how much did they give as a gift? When they got to this particular wedding. The first person I asked said that they gave, let's say, €100. The next person gave €140. The next person gave €110. The next person gave €180. The next person gave €120. The next person gave €50. Someone gave €20. And let's just say we have someone else in here. Let's say we have something like, I just want to get this distribution in a certain way. Let's say we have €150, and maybe even someone in the center in here gave €145. Okay? So I asked 1, 2, 3, 4, 5, 6, 7, 8, 9. I asked 9 people, so my sample size is 9. I asked 9 people this question: how much did you put in an envelope for a gift? Okay? Now, the thing about this particular axis here is that the data set is ordered. It's ordered from smaller values all the way through to larger values. So what I'm going to do now is I'm just going to identify the smallest response. That was here. I'm just going to put a little line here. I'm going to identify the largest response, which was here. I'm going to put a line here. Okay? And now what I'm going to do is I'm going to identify where the median is. And to calculate the median, we're going to triangulate. Cross off the smallest with the largest. Cross off the next smallest with the next largest. Cross off the next smallest with the next largest. The next smallest with the next largest. And in this case, I'm left with one in between. So this here is the median response. I'm just going to put a larger bar here. Okay. So what I now know is that what I've now done is that I've split my data set. Okay. This is all scaled correctly. Okay. This is on a scaling here. I've split my data set up into 2 intervals. 50% of the values are over here, and 50% of the values are over here. Okay, so I can see that the median is in here. This is the median value. Okay, the median splits the data set up into 2 equal portions. Half the responses are less than it, and half the responses are greater than it. Okay. So now what we're going to do is we're going to look at the first half of responses here, from here down, and we're going to split that up into a half. So we're going to take the smallest with the largest, the next smallest with the largest, and now I'm left with this value in between. So I'm left with a value right here. Okay, and I'm going to do that. Then I'm going to look at the data set from the median above, and I'm going to take the smallest with the largest, the smallest with the largest, and then the next in between, which gives me a value in between here. So effectively what I've done now is I've divided the line up into quarters. I have quarter here, quarter here, a quarter here, and a quarter here. Well, I haven't divided it into quarters based off distance. I've divided it into quarters based off the number of observations. Okay? So what I'm going to do is I'm just going to put a bar around this here, like this, and a bar here. And what we've now generated is what's known as a box and whiskers plot. Okay, so we have our box and whiskers plot now. So you've probably seen these plots. Okay? What they represent is, how do we interpret them? Well, this is the minimum value in the data set, the person that responded with the smallest value. This is the maximum value. The value in between, this line here, is the median value. And now what we have is that this line here on the bar, if you think about it, if I walk along here from the smallest all the way through, I've covered a quarter of the data set. So this bar represents the first Q, the first quartile. Okay? If I continue on, I've covered now 2 quarters. That's called the median. If I continue on, I've now covered 3 quarters, or the third Q, the third quartile. And if I continue on, I've covered 4 quarters. So a box and whiskers plot, okay, allows us to visualize the distribution. Okay? And the visualization is telling us in relation to the spread of the data relative to each other. Okay? We can see that there's a large spread with respect to the first quarter of values, whereas the last quarter of values are quite tightly coupled together. Okay? There's not as much spread between the people that are at the top, the quarter of people that are at the top. The people that are in the 75th percentile, okay, or that are above the third quartile mark, not much distance between them, whereas these guys have a larger distance. Actually, if we were to draw the histogram of this histogram would look something like this. The bulk of the curve would be in here, and it would be this long tail here. This is indication of a negatively skewed data set, if that makes sense. Yeah. Okay. So just to keep an eye on it, this is, since we were talking about medians, we can also take the concept of medians, and we can delve down deeper by splitting the first 50% up into 2 quarters and the second 50% up into 2 quarters, which gives us this idea of what's known as a box and whiskers plot. So that's just something new to throw in here. Okay, but with that said, what we now have is we still have just covered our 2 basic statistics. We've covered our mode, and we've covered our median. The next calculation that we're probably interested in is the next measure of central tendency, which is known as the average, or it's known as the mean. Okay. So what I'm going to do now is I'm going to take our data set. Okay, once again, let's just take our data set, the raw data. Okay, we'll take our raw data here. So I'm going to take, once again, let me just put it here: 4, 3, 3, 2, 1, 4, 5, and 7. That's our raw data. Okay, it's measuring our variable. The question that we asked was, how many siblings do you have? Okay, and what I want to do is I want to calculate the mean. So I want to calculate the mean of that particular data set. Okay, now, because this is sample data, we have a particular symbol that we use to calculate the mean, and it looks like this. It's called X bar. X represents individual observations, and X bar, when you see an X bar in a textbook, it means the sample mean. It's the average of your particular sample. Okay? And we can calculate it. We have a formula that allows us to calculate it. The formula says what you need to do is you need to calculate 2 numbers, the sample size, n, and also you need to sum up all of your observations. Okay? So to calculate the mean value, all you do is, so this is sigma x, the sum of all the observations. X always represents an observation. So sigma x means the sum of all observations. So you add up all your observations, which gives you a total amount of items. Okay? And then you divide it by how many things you have. Yeah. Okay. I suppose really what the mean is calculating in this case is that if these were shots of Jägermeister, 4, 3, 3, 2, 1, 4, 5, and 7. If I add them all together, it gives me the total number of shots of Jägermeister. And let's say I have n people. If I divide that n into the total number of shots of Jägermeister, what the mean tells me is how many shots each individual should get so that everybody gets the same number of shots. It's a very fair statistic, if that makes sense. So our mean in this case, our X bar, is simply the sum of these observations here. It's going to be 4 plus 3 plus 3 plus 2 plus 1 plus 4 plus 5 plus 7 divided by the sample size. Well, how many observations have we got? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 observations, so we're going to divide that by 8. So our X bar, our mean, let's add them up. 4 and 3 is 7, and 3 is 10, and 2 is 12, and 1 is 13, and 4 is 17, and 5 is 22, and 22, and 7 is going to give us 29. So we have 29, which needs to be divided by 8. Now, you can use your calculator for this. So if we just come across here, if we take 29 and we divide it by 8, we get a value of 3.625. So we get our X bar is 3.625. That's now our average. Okay. Now, so on average, people have about 3.625 siblings. Yeah, probably doesn't make sense. So we'd probably round that to the nearest whole number. That is 4 siblings. 4 siblings on average. So really, with respect to this particular data set, okay, the modal response was between 3 and 4. The median response was 3.5. And the average response was 3.6. So you can see that our responses are actually quite similar across our 3 measures. Yeah. Now, just when it comes to looking at the mean the median and the mode. Okay? If we had a histogram, okay, let's say something like this. So let's say we have a histogram. Now we know how to draw the histogram. We generate our frequencies, and then from our frequencies we create our bins, our classes. We calculate how many things fall within each class, and then we draw our histogram. We've done that in Excel. So let's say we have our histogram, and our histogram looks like this. Let's say it's perfectly symmetrical. Right? Let's just say it's something like this. Right? This is meant to be perfectly symmetrical. Right? This is how much money did you spend? So money spent. Right? And this axis along here is the frequency. How many people spent that amount of money? Okay? And this is perfectly symmetrical across here. Let's say this is 10, 20, 30, 40, 50, 60. You can see that most people spend between 30 and 40 euros. The same number of people spent between 20 and 30 euros as spent between 40 and 50. The same spent between 10 and 20 as spent between 50 and 60. So what we end up with is a symmetrical distribution. The distribution looks symmetrical. Right? Now, what we know about the mean, median, and mode when it comes to symmetric distribution is that, well, the median splits the data set up into two equal portions. So the median is going to be here. Right? Because half the area under the curve is going to be to its left and half it's going to be to its right. The area signifying the height of the bars. Half of the height of the bars are over here and half of them are over there. The mode is also down the middle, right down the middle here, because that's the most frequent bar, and halfway between them, yeah, is a good indication. That's actually right in between here is probably the highest point, yeah, even though that's a flat bar. And also the mean is in there. It's right in the middle because that's the average. That's where I'd hold that particular plate if I wanted to balance it. Okay. So what we now know is that when we look at our numerical measures, if the mean equals the mode equals the median, well, just from a numbers perspective, we then know that the distribution is symmetrical. Right? Now, let's see what happens. Let's see what happens when we introduce some outliers. Right? So when we introduce some outliers, okay, so this time I'm going to draw my graph, right? And I'm going to draw a positively skewed graph, something like this, just to keep it simple. And let's say we have a bar over here. But if I draw the curve over the top of this, I end up with a tail going out in this particular direction here. Okay. So, well, the mode is still down the middle. Okay. The mode is still going to be here. It's going to be within the modal response. Okay. The median is going to split the data set up into half. Okay. Well, let's think about it. Yeah. Half would be this bar and this bar. Yeah. Along with, and halfway down there, that's sort of the same amount of area. Okay. But hang on. We've also got some people over here and some people here. Okay. So actually the median is probably going to be a little bit closer in this particular direction here. The median is probably going to be down here somewhere. Okay. But still going to be pretty there. This area here is meant to be the same as this area over here. Okay. But the mean value, the mean itself, just as an example, the mean is going to always get pulled in the direction of the outlier. Okay, the outlier. Okay, so if really what I'm saying is this: if the median is less than the mean, okay, when we look at it from a numerical perspective, that's an indication of, well, positive skewness. Okay, if the median is greater than the mean, that's an indication of negative skewness. Okay, so all I'm really trying to say here is that when we look at it from a numerical perspective and look at the numbers, we can get an indication from the numbers, an indication of what the actual distribution, what the graphical representation of the distribution actually looks like. Okay, So let's just keep that in mind. So now what we've done is that we've summarized our data, okay, by using what's known as our three measures of center: our mean, our median, our mode. Let's say the mode, MO, is the most frequent, right? The median, the M and the I being middle, okay, is the middle value, and the mean, okay, with the A, okay, is the average, right? There are three measures of three ways to look at the data from a numerical perspective with respect to tendency, with respect to tendencies, right? Now, let's just go back to the idea here, okay? Okay, we can go back to the idea of a symmetric distribution, right? So the symmetric distribution goes something like this. And the mean is down the middle. Okay, so here's our mean. Okay. So there's our mean is down the middle. But don't forget, people have responded with values. Okay. People have responded with values over here, and they have responded with values over here. Okay. Effectively, everybody is a little bit of a distance. Everybody is a little bit of a distance. Some people have the same distance, they're a little bit of distance away from the mean over here, and people are a little bit of a distance from the mean over here. Okay. And then what we're interested in this is what is that average distance? Okay. Really, what I should have said here is that people's responses are dispersed. They're dispersed. Okay, dispersed. Okay, around the mean value, and that dispersion, okay, ends up with everybody being a distance, yeah, from the mean. So if we take all them distances and bring them all together, okay, we can calculate what's known as the average distance. And actually, this I'm not doing the let's say the maths behind it. Well, from a sample perspective, we have a formula that allows us to calculate it. S is we calculate every observation, we take away the mean value, we square it, and we divide by how many observations there are, less one. Okay, this is just a formula. Okay, we're not interested in the formula, and we get the square root with that. What this calculates is the average distance observations are away from the mean value. Okay, this is called the standard deviation. Okay, so the standard deviation is an interesting statistic for us. It is the average distance, okay, observations are away from the mean value. Okay. Now, I'm not going to do the calculation. Okay? We're going to rely upon Excel to do that calculation. I have got videos up that does the calculation of the standard deviation. Okay. But alongside the standard deviation is what's known as the variance. And the variance is what's known as the average squared distance. Squared distance. Right? Observations are away from the mean value. Okay, so if when we generate in Excel, when we generate our descriptive statistics, descriptives, okay, we're going to be interested in, from our descriptive perspective, we're going to be interested in the mean, the median, and the mode. We're going to be able to explain what them characteristics are, okay, and actually just maybe just report them, okay. But also an important characteristic that we're going to be interested in is what's known as the standard deviation, which is the average dispersion people are around the mean value. Okay, so let's just keep that in mind. Okay, now I think I have people here that joined us, yeah, from different parts of the world. There's someone there from Sri Lanka, yeah, and so thanks for joining. But this was actually a class, yeah, for a group of students that we have in NCI, which is research methods with qualitative and quantitative methods. So what I'm going to do now, guys, is I'm going to say goodbye to you because I'm going to go back over to our teams and have a chat with my class. So what I'm going to do now is I'm just going to mute YouTube, and I'm going to come back over onto Teams and have a chat with my students, that are taking this class this evening. Okay.